Okay, question 26. This Q here should be T. So we've got this metal, this metal, this metal, and then we've got the salts. Okay, so we all know that most reactive metals are placed further down the electrochemical series. Okay, we've got 1 experiment, 2, 3, and we need to order the metals. So where there's an S, that tells me they're the metals that we're talking about. Okay. We need to rank them from least reactive to most reactive using this information. All right, so what have we got here? Okay, there's a reaction between the T and the R ions here. Okay, so that tells me that T reacts with the R ions. That's interesting. Good to know. That tells me that T must be more reactive than R. Okay, because the R ions are going to be here. And T is going to react with R because there's a downhill line there. Okay, so I could say that T is more reactive than R. I definitely know that. And here, so there's no reaction between the T ions and the S metal. Okay, so that tells me that the S must be higher up than the T. Okay, it must be less reactive than T, because if I put an S here, it's going to be an uphill line from the T cations to the S. Okay, and what does this also tell me? Okay, it tells me that S doesn't react with R either, so that makes sense too. Okay, so I've got my S ions here. S won't react with the R cations either. So in that case, if reactivity increases as we go down the series, that tells me that S is the least reactive, then we've got R, and then we've got T. So that's one way of kind of picking that apart, just seeing that T reacted with R, so T must be below R. Okay, T reacted with the R cations, and we all know that on the same line there, we've got the metal of the metal ions. So, for example, Pb2+, got Pb on the same line. So if T did react with the R ions, T must be below the R to get that downhill line. Okay, T must be more reactive than R. And then we saw that the T ions here didn't react with the S metal, so the S must be above the T to get that uphill line. Okay, so less reactive than T because it didn't react. And S didn't react with the R either, so the S must be above the R, which is where I placed it as well. Okay, so that is that. Now that's one way of approaching it, probably the quickest. I just want to have a look at just reading this equation here. So hopefully you can see that the T has been changed into a T cation. And in this case, what's happened? Well, I need to add 2 electrons here. This is what's called oxidation. So the T metal has oxidized, and at the same time, the R cation has been reduced to be the R metal there. So there was a reaction between the T metal and the R ions. So that tells me that the T metal, therefore, is less reactive than the R ions. Sorry, it's more reactive than the R metal. Okay, to get that downhill line between the T and the R. And then what we saw was that S didn't react with the T cation, so it has to be above, and the S didn't react. So it didn't react with the T ions, and it didn't react with the R ions, so it has to be above them. Anyway, so that's the main idea behind those kinds of questions. You just have a look at what's happening. Usually the best thing to do is, okay, what metal hasn't yielded the most reactions? So which metal didn't react with most of them? And that tells you that it must be pretty high up if you're getting all these reactions going down. If you know, so from the cations, it's going up. S didn't react with this cation, didn't react with this cation, didn't react with that one, didn't react with that one. So it tells you that it mustn't be very reactive. So it must be kind of high up on the series here. And then you sort of try and pick apart the other information to place the other ones.